Welcome to the channel. We're so glad to have you here. In today's video, we'll be exploring something exciting, useful, and interesting. Whether you're a new viewer or a returning subscriber, thank you for being part of this community.
A tornado index that meteorologists almost never see climb above 1 is sitting at 8 over Quebec in northern New England right now as you watch this video. Not over Oklahoma, not over Kansas in the heart of tornado season, over Quebec in July. And that single number, 8, on a scale where 1 already means you should be paying close attention, is only the first piece of a weather story that gets considerably more serious over the next 10 days. Because what is producing that number today is not a single isolated storm system. It is one shift in the upper-level wind pattern over the entire eastern half of North America. One reconfiguration that switched on in the last 24 hours and is now threading 4 separate weather hazards together in a chain. A tornado outbreak, a multi-day severe weather siege, a flooding threat, and a Gulf of Mexico tropical system that may or may not have a name by the time this week is finished. Each of those hazards feeds from the same source. Each one takes its turn from the same locked jet stream pattern. And the part that forecasters keep coming back to, the word they keep using that deserves your attention, is not unusual, it is not historic, it is deadly. That is the word appearing in the National Weather Service and Storm Prediction Center discussions for this event. Deadly severe weather potential for portions of the Northeast today. Deadly flood threat targeting Texas. Dangerous tornado risk for Quebec and Maine that forecasters describe as some of the highest parameters they have ever seen at this latitude. If you are anywhere on the eastern seaboard, from Maine to Florida, from the Ohio Valley to the Carolina coast, what the next 10 days bring to you depends almost entirely on exactly where you are standing when each piece of this pattern takes its turn. This video is going to walk you through every piece day by day so you understand what is actually happening and why the forecasters watching it are taking it as seriously as they are. Subscribe right now and turn on the notification bell before this video ends, because the situation is evolving in real time, the tropical component in the Gulf is still unresolved, and when the significant updates break over the next several days you will want to know before they arrive at your front door rather than after. Start with the architecture, because to understand why so many different hazards are being generated at once you need to understand the single structure that is driving all of them. High in the atmosphere, roughly 30,000 to 40,000 feet above the surface, the winds that govern large-scale weather patterns across North America are organized into the jet stream, a fast-moving ribbon of air that separates cold polar air from warmer subtropical air. In a normal summer pattern, the jet stream sits well north of most of the populated eastern United States and allows relatively settled weather to dominate across the region. Storms track along it or below it in predictable sequences. And the average person in Boston or Washington or Charlotte experiences the summer as a progression of heat and humidity interrupted by occasional afternoon thunderstorms. What has happened over the last 24 to 48 hours is a fundamental reorganization of that pattern into something meteorologists call a dipole. Two large-scale features locked side by side, each amplifying the effects of the other. On the western side of the dipole sits a massive dome of high pressure centered over the northern plains and upper Midwest. This ridge of high pressure has been running temperatures 20 to 25 degrees above normal across a broad territory. Billings, Montana approached 108 degrees Fahrenheit. Salt Lake City challenged its all-time record high, not its record for the date, but the highest temperature ever measured there in any month of any year. That is not an ordinary summer heat wave. That is a ridge powerful enough, deep enough, and stubborn enough to fundamentally. Eastern side of that same pole, directly opposite the dome, the jet stream has sharpened into a deep trough, a southward bend in the upper-level winds that is pulling cold air down from Canada while simultaneously acting as a highway for the disturbances tracking southeast out of that cold Canadian air and into the warm, humid, deeply unstable air sitting over the northeastern United States. These two features are not independent. They are the opposite ends of the same wave. The dome in the west is the engine. Its eastern flank is what meteorologists describe as a high-speed conveyor belt, a zone of accelerating northwest winds aloft that steers every disturbance that approaches from Canada directly into the warm moist air mass sitting over the northeast, with enough wind shear stacked through the atmosphere to organize those disturbances into severe, long-lived storms. Without the dome in the west, there's no conveyor belt in the east. They are one structure read from two different ends. That conveyor belt is what is loading this whole 10-day sequence. It is active today. It reloads for the weekend. And it is the same pattern whose trailing southern edge sags a boundary down into the Gulf of Mexico, where something is beginning to try to spin up on warm water that is currently running 2 to 4 degrees Fahrenheit above the historical average for mid-July. One pattern, one conveyor belt, for hazards arriving in sequence. The first hazard is today, and it is the one that produced that number 8 on the significant tornado parameter. The Storm Prediction Center has issued an enhanced risk, level 3 on a scale of 5, for severe thunderstorms across northern New York and northern New England on July 14, 2026. That designation covers a broad region including Montreal, Quebec City, Ottawa, Gatineau, Burlington, Vermont, Portland, Maine, and the surrounding areas. The agency's own discussion describes what is setting up in unusually direct terms, a favorable thermodynamic and kinematic environment across northern New England. A significant threat for severe and damaging winds, some reaching 75 miles per hour and above, large to very large hail with isolated stones larger than 2 inches. And what the discussion explicitly states, multiple tornadoes may occur, and a narrow corridor of greater tornado potential, including strong tornadoes, exists this afternoon and evening across parts of western into central Maine if supercells can maintain their structure as they track southeast. To understand why this is being taken so seriously, consider what a significant tornado parameter of 8 actually represents. The STP is a composite index that blends 4 separate atmospheric ingredients: instability, which measures how violently the atmosphere will respond when air is forced upward; deep layer wind shear, which measures how sharply the wind changes direction and speed from the surface through the upper atmosphere; low-level rotation available to individual storms, and how close to the ground the cloud bases are forming. A value of 1 on this index means all of those ingredients are present and significant tornado potential exists. A value of 8 means all of those ingredients are stacked to a degree that would produce headlines even in Oklahoma City or Wichita during the heart of spring tornado season. That value of 8 is appearing in model guidance for southern Quebec on the afternoon of July 14th. The specific weather setup producing it goes like this. A sharp cold front is forecast to trigger thunderstorm development north of the St. Lawrence River beginning around 2 in the afternoon Eastern Time, reaching Quebec City and Trois-Rivières between 4 and 5 in the afternoon, before tracking southeast into the eastern townships, the Gaspé Peninsula, and northern New Brunswick through the evening. As those storms move south into northern New York and northern New England, they are moving into air with surface dew points running through the 70s Fahrenheit, and instability values of 2,500 to 3,000 joules per kilogram of Cape near the Canadian border in the late afternoon hours. Against that instability, more than 50 knots of deep layer wind shear is in place, a wind shear that stretches nearly perpendicular to the front in a way that specifically favors the development of discrete supercell thunderstorms. Supercells are not ordinary thunderstorms. They are the rotating kind, the kind that develop a persistent deep rotating updraft called a mesocyclone that can sustain themselves for hours instead of collapsing in 30 minutes the way a typical summer pulse storm does, and that are responsible for the large majority of tornadoes rated EF2 and stronger in the continental United States. What the atmosphere over northern New England is being set up to produce today is discrete rotating supercells, not the messy, disorganized clusters that northeastern summers usually generate. The Storm Prediction Center's outlook specifically notes that the environment will be capable of supporting both discrete supercell thunderstorms and organized lines of storms. Some of the strongest storms could produce wind gusts exceeding 70 miles per hour, capable of downing trees and damaging structures across a wide area. Quebec has already seen 3 confirmed tornadoes in 2026, according to the Northern Tornadoes Project from Western University. The most recent, an EF2 rated storm, occurred on July 1st near Lac-Saint-Jean, roughly 400 kilometers northwest of Montreal. July 14th is shaping up to be the biggest severe weather threat the region has seen this year. For anyone in the threat area, and that includes major communities like Montreal, Quebec City, Ottawa, Burlington, and Portland, the advice from every forecasting agency is the same. Know your shelter plan before afternoon. Do not wait for a warning to figure out where you will go. A storm warning in this environment can mean you have minutes, not hours. An interior room on the lowest level of a solid structure, away from windows, is the safe answer. Basement if you have one. The storms are expected to push through northern New England overnight and begin weakening as they approach the Boston corridor, where the daytime heating that was feeding them will have faded. But here's what separates this event from a single severe weather day. The conveyor belt does not stop when today's storms end. It reloads. And the reload is aimed at a much larger population center. By the end of this week, Friday, July 17th into the weekend, the same northwest flow pattern that is firing supercells over Quebec and Maine today shifts its attention to the mid-Atlantic states and the northeast corridor, and it does not let go for the better part of 4 days. This is the second phase of this event, and the distinction in meteorological language between what is happening today and what happens this weekend is worth understanding clearly. Today is a single act. The weekend is a siege. The Weather Prediction Center's extended forecast discussion, issued July 14th, describes the setup explicitly. A strong upper ridge over the central United States will continue to cause dangerous heat across the northern plains and Midwest through the end of this week. The eastern portion of that ridge, joining with a subtropical Atlantic ridge, should lead to hot temperatures across the Ohio Valley into the mid-Atlantic on Friday. An upper trough poking into the northeast should gradually shift the pattern and bring some relief to northern areas over the weekend. But in doing so, in digging that trough southeast, it drives round after round of organized storm complexes down into the corridor between Washington and Boston. The Mid-Atlantic gets the first turn on Friday, July 17th. Washington, D.C., Baltimore, Philadelphia, Virginia Beach, and Raleigh are all in the region being watched for organized severe thunderstorms. The Storm Prediction Center had drawn risk areas for this period but specifically noted in their Day 4 through 8 outlook, issued July 13th, that significant differences exist within and between ensemble guidance regarding the timing and exact nature of this pattern, and that the front's position on Friday introduces uncertainty about exactly where the highest quality moisture and instability will line up. That uncertainty is honest uncertainty, and meteorologists are acknowledging it directly rather than overclaiming. At 4 to 5 days. The atmosphere at 4 to 5 days range genuinely has not decided exactly where the boundary will be. What is not uncertain is that warm, humid air with dew points capable of supporting severe weather is being loaded into the eastern United States from the south, that the upper-level pattern is driving multiple disturbances southeast across the region from Friday through Monday, and that the primary threat from those disturbances, given the type of storm complexes this flow pattern tends to generate, is damaging straight-line winds rather than isolated tornadoes. Mesoscale convective systems, the large organized storm complexes that the Midwest and East Coast experience in summertime, are driven by this kind of northwest flow. They can produce widespread damaging wind gusts across hundreds of miles in a matter of hours, knocking out power to large areas and generating significant tree damage across entire regions. Saturday and Sunday bring additional rounds through the Ohio Valley, the Great Lakes, and back toward the East Coast. The Weather Prediction Center's discussion specifically notes that Saturday should see the core of the high precipitable water air mass shift into the mid-Atlantic, with amplifying troughing building into the northeast and embedded shortwave energy supporting an organized convective threat from Ohio into the northern mid-Atlantic. On Sunday, a low-pressure system settling over the Great Lakes region is expected to drive another round through the Ohio Valley. Tornadoes go back on the table with Sunday's setup, as the low pressure provides the low-level rotation needed to complement the instability in shear. Monday brings yet another potential round. The pattern that starts today over Quebec ends at its earliest somewhere around Monday, July 20th, northern New England today, mid-Atlantic Friday, Midwest and Ohio Valley Saturday, Great Lakes and Southeast Sunday, the whole eastern corridor Monday. That is one locked atmospheric pattern methodically working from north to south and back again for nearly a week. Away from the storm threat, the same pattern is producing significant flooding. And the flooding does not need tornadoes or wind gusts to kill people. Training thunderstorms, storms that organize into bands and move repeatedly over the same ground like a train with car after car running over the same stretch of track, have been threatening flash flooding across portions of the Mississippi, Ohio, and Tennessee valleys, where the ground is already saturated from previous heavy rain events. Rainfall rates in the most intense cells within these systems can exceed 2 inches per hour, a rate that overwhelms urban drainage systems, fills normally dry creek beds in minutes, and generates the kind of fast-moving flash flood conditions that are responsible for the majority of weather-related deaths in the United States in a typical year. In the Texas Hill Country specifically, the Weather Prediction Center is forecasting 6 to 10 inches of rainfall, with flash flood chances as high as 40% in some areas. That threat is separate from the tropical component building to the south and east, but it is part of the same larger pattern. The southern moisture plume that the Gulf flow is helping to pull north is contributing to rain totals across a region where topography, the steep creek valleys and narrow canyons of the hill country, concentrates rainfall into extremely dangerous flood events with very little warning time for people downstream. The flooding threat is one of the most underreported aspects of multi-hazard severe weather events. Wind damage is visible and dramatic. Tornadoes produce stunning imagery. But statistically, flash flooding is consistently responsible for more deaths per event than any other convective weather hazard, partly because it is harder to visualize in the abstract and partly because the warning time is often much shorter. Water in a low-lying road can appear normal-looking and still be flowing at velocities that will sweep a vehicle off the pavement before a driver has time to reverse. The rule that forecasters and emergency managers, a significant tornado parameter, it is the combination. A significant tornado parameter of 8 over Quebec in July. Enhanced risk severe weather watches covering major northeast population centers for a second time within 2 weeks. Philadelphia reported powerful storms on July 11th with wind gusts reaching 60 to 70 miles per hour that downed trees and power lines across West and South Philadelphia before this pattern even fully developed. A multi-day siege from Friday through Monday across the mid-Atlantic and East Coast. Flash flood threats in Texas and the Ohio Valley. A potential Gulf tropical system developing close to home on exceptionally warm water with declining wind shear. All of it connected through a single locked upper-level pattern, the western anchor of which is setting all-time high temperature records in Salt Lake City. The heat in the west and the severe weather in the east are not two separate news stories. They are two endpoints of the same wave. The western dome is what drives the eastern conveyor belt. The strength of the ridge over Billings and Salt Lake City is proportional to the speed of the northwest winds on its eastern flank, which is proportional to the shear available to organized storms in New England. You cannot separate the heat record in Montana from the tornado threat in Maine. They are the same atmospheric system. That interconnection is the real story of this event. Not any single storm, not any single day. The architecture, one jet stream configuration producing tornado potential over Quebec, severe siege conditions for the mid-Atlantic, flooding in Texas, and a developing Gulf system simultaneously. And the way all four of those hazards trace back to a single large-scale pattern that is expected to hold in place for the better part of 10 days. Here is how to use the next 48 to 72 hours to understand which way this resolves. For today and tonight, July 14th, the question is whether the tornado threat across Quebec and northern New England verifies at the significant ceiling the setup suggests. Reports coming out of the storm area through this afternoon and evening will tell you whether the supercells maintained their structure long enough and moved southeast in an organized enough fashion to produce the large hail and tornado threat the atmosphere was loaded for. The Storm Prediction Center's convective outlooks update at 6 a.m. and 1 p.m. daily, and throughout the day as conditions warrant. Watching those updates is the most direct way to track how the event is verifying. For the weekend, the key question is where the front settles on Friday. The Storm Prediction Center's extended discussion explicitly noted that ensemble guidance is in significant disagreement about the boundary's position across the mid-Atlantic on Friday, and that severe probabilities would be reintroduced in later outlooks when confidence improved. For the Gulf, watch the National Hurricane Center's Tropical Weather Outlook. It publishes at 8 a.m. and 2 p.m. Eastern daily. The first designation of an area of interest in the northeastern Gulf, even a 20 to 30% chance marker, would signal the forecasting agencies have decided the probability is high enough to formally flag. That threshold, not any specific model solution, is the clearest single indicator of whether the tropical component of this event is becoming a genuine concern for coastal communities from New Orleans east to Tampa and possibly northward into the Carolinas and southeast. One pattern, multiple hazards arriving in sequence across 10 days of unstable, volatile weather for the eastern United States. If you want accurate, sourced, real-time tracking of exactly how this unfolds, not exact.
The Northeast Severe Weather Event is active today. The weekend siege Atlantic July 15, 2026. Every piece of this worth after today. After today is the East Coast at the bell. Subscribe, like, and share this video to stay updated with the latest weather developments. Comment below with your location and thoughts, and join us for the next forecast update.